All right, guys, let me try to catch up to you. The exciting world of stapler analysis. What's the sample in part A? Let's start with the sample. Careful, see? What's the number 42 have to do with this problem? It's the answer life you for that. Yeah, so 42 is not got anything to do with this question at all. It's what I saw in my sample. There's no way I could say that 42 is a sample. I just randomly picked the 42 that are defective. That doesn't make any sense. Once I had a sample, I could then do some shit with it, right? But what my sample was the 210 staplers. And since I wasn't specific about where they're from, I have to assume my population was all staplers everywhere. So I would have said 210 selected staplers from the stapler factory in Tuskegee, then that would have been your population. All those staplers in the factory in Tuskegee, right? You guys understand what's happening? There wasn't enough information in there to be any more specific with the population. I have to assume it's all staplers.
I wrote selected stapler.
For where? For which one?
For population.
Yeah, see, the population is never going to be selected anything.
Okay.
The population is not selected. It's everybody, and then we select a subgroup of that. I like it. How are we doing so far? Is that okay? And then part B is actually a little bit easier. What's the sample in part B? 329 Mesa students. Messy students? Messy teacher one. And then population. Mesa students. Mesta? I like that, Jeff. All Mesta students. Okay, cool. Cool. Maybe. So you do have to think a little bit. If I throw in there anything I did, if I said 11% of the 87 selected Grossmont students are left-handed, the 11% doesn't mean shit for this question. The sample would be the 87 students, and the population would be all Grossmont students. The 11% would be the analysis I did of my sample. It has nothing to do with what the sample is. Just warn you, because I've been known to do that kind of thing. All right, what about number 2? Good old Neil Diamond. How many of you guys know Neil Diamond? Oh, the rest of you are like, I know him, but I'm going to pretend like I don't. It's an old guy, whatever. I know Shakespeare, but he's not from my time. So how many people were aged 20 to 30? 2. Is that cool? So the correct way... So do you know how old any of those 2 people in there were?
No.
No, I have no idea. What could they be? They could be 24 and 25. They could both be 27. So all this says is that there were 2 people that were between the ages of 20 and 30. Now, to be honest, it was actually 20 to 29. Because if this was 20 to 30 and this is 30 to 40, where do the 30-year-olds go? Do they go in both? Oh, shit. And that explains why my numbers on 3B are a little... Yeah, exactly. They have to be more specific to create this thing in the first place. So how many people total will sample? 10, 15, 18, 20. You guys understand what's happening? I just counted all the frequencies, and that's the total of 20. 20 people. What percentage of the people were younger than 50? Yeah, how many people were younger than 50? 10 out of 20. Cool. So 50%. Now please let this phrase tell you exactly what is the class width is how wide all the classes are. And how wide are the classes? 10. Don't make a big deal out of that. 10. And of course, based on what I said, the very first thing I said, I have no idea how old these 2 people are. I just know that they're between 20 and 30. Do you have any idea how old the oldest person was? No. But I like what somebody said. They have to be at least 90.
90.
They could be anywhere 90 to 100. There's just one person in that class. We have no idea how old this guy was. Or woman. I don't know. Somewhere between 90 and 100 years old. I like it. No.
So we just put no, right?
Yeah, you just put no. If you say they had to be at least 90, I'm like, oh, that's awesome. You said that. No bonus credit for that, but I like it. All right, so here, the stem and leaf, hopefully. Now here's the right way to do a stem and leaf. Were there any, there were 60s. All right. I couldn't remember there was, so even if there's no 60s or whatever, the lowest is 40s and the highest is 90s, right? So then I represent everybody 40s, 50s, 60s, 70s, 80s, 90s. I don't even think about it, is there any that's missing any? They all have to be there. Because then an empty spot is information. If I just don't even represent it, I'm misleading. That's misleading. People are like, oh, everybody was there. No, I have to have an empty spot and go, oh shit, we didn't have anybody in this demographic. Oh, if it's somebody watching TV shows. They're like, oh, we need this demographic and nobody watched your show. Whatever. So where are my 40-year-olds? Let's see.
We have a 43-year-old.
43-year-old, is that it?
Yep.
All right.
One question.
I'm sorry, this is grades. I'm still thinking about age.
One question.
Yes.
So we don't have to represent like 1 and 2 and 3.
Oh, definitely not. The lowest data point is 43. So that's where you start. The highest data point is 90-something. So that's where you end. So 1, 2, 3, there would be no purpose for that. It's because if you start at 4, I know there was nothing before that. So I'm not misleading anybody then. This is where my data starts. I like that. Okay, good. What about my 50s? I got 50, 50. Any more 50s?
No.
Nita. What about 60s? 67. What about 70s? I got a 70. I got a 71. 2, 2, 2. Do I have 2 70s? 170. I got that bad boy. 79, 77 and 79, right?
Yep.
What about 80s? Here we go. We got 81, 81, right? 83, 86, 86. And that's it for 80s. And then all I got left is 90s. 0135 it looks like, right?
Yes.
And what's my key going to be?
493 equals 43. Do you want equals or mean?
It doesn't matter. Yeah. Well, to be honest, the equals doesn't really make sense there, but if you write that, I'll know what you mean.
So it always has to be the after.
Yeah, without the key, I don't know if this is 7.0. Because you got to realize, this would be something you would show somebody, you wouldn't show them the data, you would show them this. So they have to have a key to know how to read this. Because this could mean 430.
Okay.
Or it could mean 4.3. Or it could mean 0.43. I don't know.
I got a question. Say you got a larger number, like 400.
See, so like I was saying earlier, will this method work for every set of data? No. If there's a lot of if it's really spread way far out, like there's 10, 20, 30, 8,000, 10 million, 14, I mean, this would be silly. Because there would be a whole bunch of empty spots, right? So there is certain data sets that this would not make sense for. I like it. Now here's the one that just sounds weird, maybe. But do you see, now, real quick, help me out. 20 to 30, and actually, remember what I just said, this would actually be like 20 to 29, so that 30 goes in the next group. Does that kind of make sense? So my classes here would be 20 to 29, 30 to 39. How many people were 20 to 29? 2. How many people were 30 to 39? 4. And so forth, right? So what we're going to do is we don't have the visual. We're going to create this kind of thing from the actual data itself. So my classes are 43 to 53, 54 to 64, and so forth. Jeff, they get the idea. All right, man, leave me alone. Let's see. I want to do that to the point where students are like, is he all right? Leave me alone. Don't talk to them like that, Jeff. All right. So It's the same exact question, and it's the same, I mean, how many people fall into these grades here? How many people had between a 43 and a 53? Then?
One. 3. Oh,
I heard the right answer.
okay, 3.
3. The 43 and the two 50s, don't they go in there? Let me let that sink in. What falls between 43 and 53 in the data? 43 does. And don't the two 50s also fall between those? So now it's really in your face what I was talking about earlier. The 20 to 30, they could have been 24 and 24, they could have been 20. They just had to be between 20 and 29 now. We know that now. So now I can just see directly from the data what is between 43 and 53? These three numbers. So there's 3. That's the frequency. How frequently does something show up between 54 and 64? Nothing. There's nothing between 54 and 64. What about 65 to 75? 1, 2, 3, 4, 5, 6, 11. Is everybody on board what's happening? Don't make too much out of this. I always get a few students who just put 10, 10, 10, 10, 10. Why do you think somebody would write 10, 10, 10? Because they're looking at the width. But this is supposed to be how often does a data point show up between these two. I already know the width is 10. Shit, don't tell me that again. Between 76 and 86?
7.
Yeah, 1, 2, 3, 4, 5, 6, 7. 87 and 97? 4. Yes, sir. Oh, you're good. What's a good quick check right now? How many total data points am I supposed to have? 20. And how many do I have? 9, 16, 20. Thank God. It so sucks to have like 817 data points and you do this and get 816. Like, oh shit, what did I leave out? Thankfully, I'm not going to give you 817 data points. I just want you to understand. How would I make, I didn't ask for this, but how would I make a relative frequency? What was relative frequency again? The percentage. So what's the total again? So now we're going to make the real freak. So there's 3 data points in here out of 20, which is 15%. This, of course, is 0%. 6 out of 20 would be 30%. 7 out of 20 would be 35%. 4 out of 20 would be 20%. Without just saying, because I know math really well, how did I make that into a percentage so quick? Because the bottom is 20. So I multiply by what to make it 100? How do I make 20 become 100? I multiply by 5. Like somebody's like, what the hell? So 5 times 20 is 100. 5 times 7 is 35. 35 over 100 is 35%. So when the bottom is 20, you just multiply the tops by 5 to get the percentage. That kicks a lot of ass. And then I could actually make a picture like that. It wouldn't be that difficult to take this data and make a picture like that. I like it. Yeah, I think that's... Any questions from this here? I love it. You guys so excited. You're like... He was about to say the phrase. Yes?
Every time you see the frequency distribution, just know that it's a stem and leaf.
Do you see how this isn't really a stem and leaf? But what's similar to the stem and leaf is that I have this, and then next to it I have something that's like a table. But this is more like a class of numbers and a number that shows up between those.
So there's like no, like, so if somebody made a mistake and actually did a histogram for that, could you possibly do that, or is there no way?
Do what? Sorry.
Histogram instead of that.
Oh, I see what you mean. It's a lot easier to make the histogram once you have this than it is just to jump to the histogram. Right? So when I say a distribution, that just means the table. I like it. Yes?
What would be the label for the first, I guess?
Well, just classes.
So is that the same thing as class width? Or is that
Well, these are the classes. How wide is each class?
10?
And to be honest, it would actually be 43 to 54 to 65, so there actually are 11 wide, to be honest.
Oh,
You see that? So the beginning number of this class is 43. The beginning number of the next class is 54. The beginning of the next class is 65. Maybe. All right, that's plenty, I believe. All right, guys.